Good evening. So today we'll be discussing the topic of data analysis using Excel sheet, which is a part of basic statistics. So data processing, it involves few basic steps. First and foremost, there is data collection, which was discussed in the last class. Then we undergo data organization and cleaning. This is to ensure a standardization to the data so that it can be easily analyzed. Next comes the data analysis aspect, which I'll be discussing further. Next, there is presentation of the data in tabular or graphical format to make it easy to understand. Finally, there is interpretation of the data by the reviewer who provides conclusion and comparisons uh, in response to the analysis. So data analysis is the process of bringing order, structure, and meaning to a mass of collected data with an aim to extract usable information and make decisions based on that knowledge. Crudely, data analysis methods can be divided into a qualitative as well as a quantitative method. Qualitative data analysis, as the name suggests, it involves non-numerical descriptive data which describes quality, opinion, and feelings. The data is collected via open-ended surveys, observation, and unstructured interviews which do not have a proper standardization. The data is analyzed subjectively and is based on observation, as the data cannot be computed or calculated. For example, open-ended patient reviews or interviews following OPD visits. The advantages include it provides a depth and detail to the data, creates an openness encouraging people to expand on their responses, and attempts to avoid prejudgment. However, it usually involves fewer subjects as the process is very time consuming. It is difficult to generalize and make systematic comparisons as there are no numerical values, and data extraction is dependent finally on the skills of the researcher. Coming to the quantitative data analysis, again, as the name suggests, it is a collection of numerical data which is objectively analyzed using statistical methods. The collection is via controlled experiments, online in-person interviews, surveys with close-ended questions. For example, reviews with a standardized questionnaire, which provide options to the interviewer or the responder so that systematic data can be extracted. So the advantages include it allows for a broader study involving a greater number of subjects and enhancing the generalization of the results. It provides greater objectivity and accuracy to the results, and this research can be replicated and compared to similar studies. However, the results are limited in details. Research is often carried out in an unnatural artificial setting, hence yielding laboratory results as compared to real-world results. Standard questions, which can lead to structural bias and false representations. Hence, qualitative analysis can be termed as hypothesis generating, whereas quantitative can be termed as hypothesis testing. In qualitative, the data is collected by unstructured techniques, and content analysis is performed on the textual, audio and visual data. Whereas in quantitative analysis, the data is collected by structured techniques, and the numerical data can be analyzed statistically. In qualitative data, it is conducted in naturalistic settings with smaller number of targeted subjects. Quantitative data can be conducted only in controlled settings and can be done in a large number of subjects. Qualitative analysis, as it is descriptive in nature, gives rise to a more greater researcher bias, where there is less chance of researcher bias in quantitative analysis as the data is numerical. Another way of statistical division of data is to divide it into descriptive and inferential statistics. Descriptive statistics is collecting the entire data set of a given population, and then we describe the entire data set by summarizing, organizing the data so that it can be easily understood. Here, as we are not inferencing the data to a larger population, the conclusion can only be applied to the sample, and it can be used when the entire study population is small and the entire data set is available to us. For example, data set of the ages of patient presenting to OPD on a day. This data cannot be inferenced to a larger population. It is a simple method of data analysis. The raw data is made more manageable and presented in a logical form. Patterns can be seen from this organized data, and hence, again, this is hypothesis generating. However, the findings cannot be generalized to a population outside the group, and the process is tedious if the population is very large. Coming to inferential statistics, here the data analysis is performed within a sample population taken from the larger population, followed by making predictions and inference regarding the whole, that is the larger population, based on probability. For example, predicting the proportion of proliferative diabetic retinopathy patient among a pool of DR patients in the population by analyzing the data sample in the patients presenting in our OPD. Here again, the advantages include that it allows to generalize the findings to a larger population, helps to assess the strength of relationship between independent variables and dependent variables, and it is a more authentic analysis. Disadvantages include it is a complex statistical analysis methods that get involved, and the inference might not be 100% accurate as we estimate by predictions only. So descriptive statistics involve classification of the characteristics of the sample population, whereas analytical involves drawing conclusions, performing estimations, and making predictions. In descriptive statistics, it is used when the entire data set is available and the study population is small, hence no sampling is required, whereas in analytical statistics, sampling is required. The tools used in descriptive statistics includes measures of central tendency, dispersion, and variability, whereas the tools used in analytical statistics include probability, hypothesis testing, and statistical significance. Descriptive statistics are likely to be 100% accurate as no assumptions are made and only the raw data is entirely used. Analytical statistics, however, makes inferences to a larger population, hence may not be 100% accurate if the sample is not a complete representation of the general population. Coming to few tips and tricks regarding data analysis in Excel. First and foremost, before we take the data up for data analysis, it needs to undergo a process known as data cleaning or scrubbing. So this is to ensure a proper standardized format is given to the data. And so this process involves removing blanks or incomplete data, removing irrelevant data. For example, there's a numerical value in the laterality of the I column. This is considered an irrelevant data. Spell checks, differences in spelling can also in the cells makes the Excel sheet consider it as a separate value of data, followed by standardization of the format of the data entered. So for example, if I want to filter the data in the laterality column, I select the column in which I want to filter, go to the data tab, click on filter. A drop down box appears next to the column. After clicking on it, below we can see all the values that are presented in the column. So if I am entering only laterality of the eye, OS and OD can be considered the standardized format. Here, left, LE or right are considered irrelevant data and they need to be standardized into the given format. Coming to a basic mathematical function, for example, calculating, say, sum of IOP in all the whole data set of the F column. So I select the cell in which I want the result to be. I can select auto sum option in the home tab, or I can go to the formulas tab and select the auto sum option. Here I have to select on the sum and then select the entire range in which I want the sum to be calculated and click on enter. Next, coming to mathematical calculations between cells. For example, this is a data set containing age of onset of diabetes of a set of patients and the present age of the patients. If I want the duration of the diabetes to be calculated, I need to subtract the value of cell 2, column 2, subtract the values of column 1 from column 2. I need to select the first cell in the column where I want the result. Go to the formula tab above. Type the formula as equal to cell 2 minus cell 1. If I press on enter, I get the entire, I get this difference. So to make sure that the range is, I can use it for the entire column, I select the first cell and drag it down as shown. Hence, the last cell contains the difference between the corresponding cells in the same row. Similarly, mathematical calculations of plus, minus, multiplication or division can also be performed. Coming to another useful function, that is the countif or countifs. It counts the numbers of cells fulfilling a specific criteria. For example, if I need to calculate the number of hand movements total number of hand movements, visual acuity in the data set, or I need to calculate IOP that is more than or equal to 20, or the number of males in the data set, I can use this option. So for nominal data, if I need to calculate the number of males in the data set, I select on the cell in which I want the result, go to the auto sum option, click on more functions, type COUNTIF, select it among the range of options given. Here, I need to select the data set in which I want to calculate as the range, and the criteria should be given as males. So it gives us the value of 6. Here, I need to point out that nominal COUNTIF option is not case sensitive. So even if we put caps on or off, it doesn't matter. Coming to COUNTIF for ordinal data, for example, if I need to calculate, make categories and define if IOP is less than 10, 10 to 21 or more than 21. For the first one, I select the cell in which I want the value, go to auto sum, more functions, type COUNTIF, okay. Then again, I need to select the range and provide the criteria of less than equal to less than 10. Okay, so it gives the number of values with IOP less than 10. If I want to select an IOP range of 10 to 21, there are two criteria involved. That is IOP of more than equal to 10 and less than equal to 21. So here, rather than typing COUNTIF, we need to go to the option of COUNTIFs, which gives us the range of more than one criteria. Hence, we select the range of the data, give the first criteria, that is less than equal to 21. Again, select the range and provide the second criteria, that is more than equal to 10. Now, if we click on OK, it gives the desired value. Now, going to an option of SUMIF, it is a similar formula to COUNTIF, but rather than counting the number of values, it gives us the sum of all the values that are, say, more than 21. So if I type SUMIF, select the value, select the range, and write the criteria as more than 21. Okay, I get the sum of all the IOP values that are more than 21. Coming to few measures, few parts of descriptive statistics which are usually encountered and can be, and Excel can be used to solve them. Coming to measures of central tendency, it is a statistical measure to determine single score that defines the center of distribution. First is mean, which is the arithmetic average and is the most commonly used in statistical analysis, usually used for symmetric distribution. Next is median, which defines the 50th percentile of the data, and more appropriate for ordinal data and skewed distributions. Mode is the score or category that has the greatest frequency. It is more valid in nominal data and has a limited statistical use. Measures of dispersion include range, that is the difference between the largest and smallest value in the data set and is used in ordinal data. Standard deviation, which measures how far away each number is from their mean. And interquartile range, which defines the difference between the upper quartile and lower quartile in a data set. It is used in ordinary data again. So coming to calculation of mean, I say if I need to calculate mean of IOP, I select the cell in which I want the result, go to the auto sum option, click on average. Or I go to the formula tab to access auto sum and click on average, select the data range and press enter. So I get the mean IOP. Similarly, median, mode, maximum, minimum values can also be obtained from the auto sum option. Briefly about data presentation, that is in the form that can be in the form of table, graphs, or charts. It is a visual representation of statistical data for easier interpretation. This is a simple bar graph which shows the presence or absence of diabetic macular edema in diabetic retinopathy across several classifications of diabetic retinopathy. So the uppermost is the main title. The y-axis presents the numerical data that are available in the cell. The x-axis contains the rows which are distributed along sections. The rows involve mild, moderate, severe NPDR and PDR. The columns, that is presence or absence of DNE, are characterized by individual bars. So bar graph is usually used to display data that are grouped in nominal or ordinal categories. Pie charts are used when usually we have a single set of data. For example, there's a distribution of male and female. Line graphs are used to show trends over time. For example, follow-up of central macular thickness in diabetic retinopathy patients. Briefly showing how a column graph is made, we select the entire data set which we want in a graphical format. Go to the insert option. Excel already provides a set of recommended charts which can be selected. If I specifically need bar graph, I go to the option of bar graph. Again, there are various designs available. I can select one. The topmost area shows me the chart title which can be clicked and renamed. Selecting the chart gives me options of chart elements, which include the addition of axis titles, data labels, for example, that is the numerical value in each column, and a data table, which will show a tabular format of the data. Final step is data interpretation, which is adding meaning to the information provided by the analysis by making connections, comparisons, and exploring causes and consequences by the researcher. So this is in brief about data analysis. Thank you.
Very well presented, Ayushi. I think you taught us a lot about Excel that many of us don't know. And nice, crisp presentation.